good afternoon, good evening, wherever you are. So I'll continue on with chapter 17. I'll do a question from 17F, which we sort of covered last lesson, and then move on to 17G, the harder ones, particularly the three circle problems. So to start with, I've written up a question here from 17F, question 7. So you may have already had a go at that. Hopefully you have had a go at it and don't just sit here and wait for me to do them on the board. If you've had a try and got it right, great. If you've had a try and got it wrong, then hopefully this will make things clear for you. Okay, so 17F, it talks about a bag. A cube is drawn from a bag. There's two bags. Bag one's got 6 red and 10 black, or blue, whatever it was. Bag two's got 7 red and 3 blue. We take one from bag 1 and then from bag 2. So one from bag 1 and then bag 2. So I've drawn a tree diagram to show that with the respective probability. So from bag 1, probability we get a red one is 6 out of 16. The probability we get a blue, I'm not sure if it was blue or black, was 10 out of 16. Then we move on to bag 2. And both of those are the same. Whatever we did in bag 1 isn't affecting bag 2. Right. So bag 2, there's 10 altogether, so there's 7 tenths red, 3 tenths blue, 7 tenths red, 3 tenths blue. Okay, so the probability we get a red and then a red is 6/16 times 7 tenths. I could have simplified, cancelled down, but in some ways it's best just to have it all with the same denominator, and then it's easy to see, because some will cancel down more than others. I guess with this one I could have easily just called that 3/8 and 5/8, but anyway, 6/16 times 7 tenths gives me 42 over 160, 160, 160, 160, 18 over 160, 70 over 160 and 30 over 160. If I've done it right, then that should add up to 1. So I've got 30 and 70 is 100, 180 and 42 is 160 over 160, alright? So, yeah, there's every chance I've still done something wrong, but at least that adds up to 1. What's the probability that they're the same colour? Well, there's the same colour, red, red, and that's the same colour, blue, blue. So 42 over 160 plus 30 over 160 gives me 72 out of 160. By all means then, cancel down your final answer, but I deliberately didn't cancel them down here just so that I could compare those numbers a bit more easily and make sure I did add up to 1. Okay, the second bit's a little bit trickier. So it's a conditional probability. I can't remember how the question is worded. Given that the two cubes are different colours, what's the probability that the red bag came from bag 1? I think that's what it was. So for conditional probability, the probability of A given B is the probability of A intersection B over the probability of B. Probability of A intersection B, probability of A given B equals the probability of A intersection B over the probability of B. Alright, so that's in your data booklet, but it's just the way, the order that it's in. The probability of the intersection over the probability of B. So the probability of the intersection, red from bag 1 and different colours, over the probability of different colours. Alright. So different colours are these two. So the total of different colours is 88 out of 160. The probability of red from bag 1 in different colours is just this one, so 18 out of 160 over 88 out of 160, which of course is just 18 out of 88, which is 9 out of 44. Okay, so the conditional probability can be a little bit tricky for second language students, especially as you all are. Just trying to work out exactly what it means and what the words mean there. So you need to have plenty of practice at those and try and understand which bit is given. If this happens, given that this has happened, what's the probability that that happens? All right, so it's conditional probability. Let's take it a bit further before we move on to 17G. So with conditional probability, if events are independent. What does independent mean? Independent means that the probability that one happening doesn't affect the other. It means the probability of A intersection B is the probability of A times the probability of B. Alright? So, you know, for independent events, okay, we know the probability of A intersection B equals the probability of A times the probability of B. Alright, so the probability of A given B, if they are independent, is the probability of A intersection B over the probability of B. That's actually not for independent yet, that's in general. But now, if they are independent, then the top line becomes probability of A times probability of B. So it's the probability of A times the probability of B over the probability of B. They cancel out. So it's just the probability of A. The probability of A given B. Right, what's the probability that I throw a 6 on a dice? 1 out of 6. What's the probability that I throw a 6 on a dice given that it's a Monday? Well, it doesn't make any difference. It's still 1/6. So, they don't affect each other, whether me rolling a dice, whether it's Monday, whether it's raining, whether I'm rolling it with my right hand or rolling it with my left hand, or with eyes closed or eyes open. It's not affecting it. They're independent events. Right? And again, often events are not as obvious as that to be independent. For mutually exclusive, the probability of A intersection B is equal to 0. Therefore, the probability of A given B is the probability of A intersection, we'll write that, probability of A intersection B over the probability of B, which is 0 over the probability of B, which is 0. For mutually exclusive events. What's the probability that I throw a 6 on the dice, given that I've thrown a 3 on the dice? Well, 0. If I've thrown a 3, it can't also be a 6 on the same dice. So, there's no intersection, so the probability of A given B must be 0. So that's sort of an alternative definition for conditional probability or for independent events and mutually exclusive events. Okay, moving on to 17G, further Venn diagrams. Looking at it, I thought, this is all getting into 3-circle problems. And there's only one 3-circle problem there, which I've done, but they're quite common in the exams, and so you need to make sure you've got plenty of practice with those. All right, so 3-circle problem. I've got A, B, and C overlapping. Some of those regions may have no elements in them. They may have no probability, as we'll see shortly. But basically there are 8 different regions. There's region 1, which is outside the whole lot, and then 2, 3, 4, 5, 6, 7 and 8. Alright, so region 1, that's everything outside A, B and C. So I can write that as A union B union C, which is all of that, complement. A union B union C, A union B union C, everything in any of those circles, complement, meaning outside that. I could have said it's A complement, intersection B complement, intersection C complement. Everything which is not in A and also not in B and also not in C. And where do they overlap? Everything outside there, so region 1. In fact, we find that there's more than one way to express what the region might be. Region 2, this one here, it's in A, but it's not in B or C. It's outside B and C. So I can write that as A intersection B complement, intersection C complement. It's in A and it's not in B and it's not in C. I could have said it's A intersection brackets B union C complement. That would have worked as well. Region 3 here is in A intersection B but not in C. So that's A intersection B intersection C complement. Question region 4. And so probably, you know, a good thing for you to do is to draw up your own table here and see, you know, I mean, by all means have a look at these first, but then see if you can work out how to express each region. I think the easiest way is just using intersections, but, you know, there's more than one way to it. Question region 3 is A intersection B intersection C complement. So region 3 here, it's in A and B, but it's not in C. Region 4, just like with A, it's in B, but not in A and C, so B intersection A complement, intersection C complement. 5 is this bit here, and that's like 3, it's in A and C, but not in B, so A intersection C, intersection B complement. 6 is probably the most important region there, because that then, you know, if we can find the bit right in the middle, A intersection B intersection C, it's in all 3 circles. Once we've got that, then we can work our way out to get the rest, as we're all fine with this one here. So 6 is A intersection B intersection C complement. So 3 plus 6 would be A intersection B, 6 plus 7 would be B intersection C, and 5 plus 6 would be A intersection C, just like we've done before with the 2 circle problems. 7 and 8 in the same sort of way. Okay, the same will still apply as with 2 circle problems. So the probability of A union B probability of A union B is A plus B minus the intersection. Of course it is. You know, with the 2, whether there's a 3rd circle there or not, the probability of the union is the probability of A plus the probability of B, but we've counted this bit twice, so we need to take it away once. Probability of A union is probability of A plus the probability of B minus the intersection. Probability of the B union C, again the same thing. A union C is A and C minus the intersection. If I've got the 3 circle problem, then the probability of the union is the A plus the B plus the C. But I need to take away that intersection and that intersection and that intersection. So it's the probability of A plus the probability of B plus the probability of C minus the intersection, minus the intersection, minus the intersection. Okay? That means that I've got 2, 3, 4, 5, 7 and 8. I've got all of those bits. But let's have a think about 6. What's happened here? I've counted it once in A, once in B, once in C. I've taken it away once here and another one here and another one here. So overall I've had it 3 times, taken it away 3 times. It's not included, and therefore I need to add that on at the end. Okay? So the A union B union C is the A plus the B plus the C minus each of the pair intersections plus the little bit in the middle. Okay, so 17G question 3, they tell us the number in the universal set is 145. I don't know if I've got all the information I need from this one yet. 10 would not need any of the, oh yeah, I've got that yet. Alright, so I've called it spaghetti and veggie curry. It's a bit confusing because you've got C for curry and C for chili, so hopefully I haven't mucked this up here. I haven't worked out the answers yet. So spaghetti and chili and veggie curry. Alright. Number in this here, that means the universal set, that means the whole lot. There are 145 students altogether, and they tell us that there's 10 outside. Alright. We know that, so we're given this middle bit, there's 12 in the middle. Okay. S intersection C. S intersection C here is 35. 12 already there, so there must be another 23 there. S intersection C. C intersection V is 24. So that plus that is 24, there must be 12 and 12. S intersection V is 20, so there must be 8 here. Okay. Number in S is 43. There's 20 and 20 that already got 43, so there must be 0 who only eat the spaghetti. Number in V is 80, so there's 20, 32, 48 there, I think. Let's just set 48 and 12 is 60 and 20 is 80. Okay, so we've got everything there except this bit here, and we haven't used this bit. So, you know, we can say altogether there's got to be 145. Alright, 48, 12 is 60, and 20 is 80, and 23 is 103, 123, I think that makes 22 in there. Hopefully that's right. Now we can answer the questions. Draw a Venn diagram showing this information. Yep, done that. How many students would eat only spaghetti bolognese? So let's finish this over here. Or number. So they're not asking for the probability, they're asking for the number. The number in S intersection C complement intersection V, a V complement. And you don't necessarily need to write it in that form, but we're answering the question, how many would eat spaghetti but not that, and 0. Okay, the next question they've asked, how many students would eat chili? That's the whole, not only chili, but how many would eat chili? I think that's 45 and 24, might be 69. 45 and 24. Now I made a mistake there. I wrote down the answers, everything 79. Let's check the overall. 145, so I've got 48, 60, and 20 is 80, 103. 13 and 22. How many would eat chili? 45. That's 69. I think their answer is 79. Let's see how we go on the rest of them. What's the probability the randomly selected student would eat only one of the 3 meals? Only one meal is this and this and this. 20, so nothing, plus 22 plus 48, that makes it 70 out of the whole lot. 45. For spag bol, 80 for veggie curry, 20 for spaghetti and the veggie curry, 24 veggie curry and the chilli, 35 for the chilli and the spaghetti, 12 eat all 3, 10 will not eat any, 145 altogether. Okay, let's just check. I'm getting some wrong answers here. 0, 23, 32. Okay, so in their solutions they've got 32 here. We've got 12 in the middle. Number of there, there's 10 outside. S intersection C is 35, S intersection C is 35, V intersection C is 24, S intersection V is 20. The total number there should be 145, 48 and 12 is 60, and 20 is 80, 103, 125, 139, that should be 32, shouldn't it? No. Let's check that again. 48, 60, 80, 103, 135, 145. Okay, so that's 32. So number in C only is 55 and 24 is 79. 45, we can cancel that down to what they've got. The next question they've asked is, given that a student would only eat one of the 3 meals, what's the probability they would eat curry? Okay, that's condition probability. Probability of something given only one, so curry given only one. Right? Is the probability of only curry over the probability of only one. Right? Probability of only curry is 32 out of 145 over the probability of only one, we've already worked out that's 80 out of 145. So we're left with 32 out of 80, or 4/10, 1.4. Okay. Given the student E, given that a student would only eat one of the 3 meals, what's the probability that they would eat curry? Well, again, I've got a different answer from what's in the book, I think. Let's try the last one. Find the probability that a randomly selected student would eat at least 2 of the 3 meals. At least 2. At least 2 means 2 or 3. Probability of 2 or 3. So that's not this, not this, not this, and not that. So it's this, and this. So 20, 32, 55 out of 145. 5 goes into that, goes 11 out of 29. Hallelujah. Alright, so E, they've got a different answer. Given the student only one of the 3 meals, what's the probability that they would eat curry? Alright, so we've got this, and this. If they've only eaten 1 meal, then, I mean, these numbers are, curry is this one, isn't it? The veggie curry, not C for this one. So I want 48. Probability only curry is 48 out of 80. Is 0.6. So that C is confusing. That C stands for chili. So if you were going to make up that question, surely you wouldn't have 2 starting with the same letter. That's just a bit awkward. So their answers are all correct, and I think mine are now as well. Alright. So that leaves us with 17H, and so I'll do that shortly for you. Okay, that's it for now.